Consider the area of a triangle bounded by y equals 4x and x equals 0 and 4. So we'll do a quick sketch of that. We've got a slope of 4. So let's try to make that suitably dramatic here. There we go. And let's make that 4 here. And that would make this 16. Y equals 4x. And the area we'd be talking about is this region here. So first off, we can get that region, of course, as a triangle. And that's, of course, going to be 1/2 base times height. And that's going to be 1/2 times 4 times 16, or 8 times 4, which is 32 square units. Okay, so this basic shape here, we can calculate the area using what we already know, areas of triangles. We can confirm for ourselves that the fundamental theorem gives the same answer by noting that the area is the same thing as the integral from x equals 0 to 4 of 4x with respect to x. Or little rectangles, each of height 4x times delta x's. Okay. Now, how does this work? We identify the little f function, that's the 4x part, and then we say that leads to the antiderivative, which would be 4x squared over 2, and we can check that when we differentiate that, the derivative of 4x squared over 2 will be 2 comes down, cancels, will be just 4x. So our integral can be evaluated by the fundamental theorem. Well, let's put plus c at the end. We should do that. The fundamental theorem will let us replace this whole complicated integral with simply 4x squared over 2 plus c evaluated between x equals 4 and x equals 0. That interval that we're interested in here. We can tidy up a little bit first. Let's do that. Cancel that and get a 2 out front of all that. If we do that, we're going to have 2x squared, well, that's 2 times 4 squared plus c, minus the 2 times 0 plus c. That's again f of b, or f of 4 in this case, minus f of 0. That's the fundamental theorem lets us do. And that will equal 16 squared times 2. Oh, 32 square units. Which is exactly what we found using the triangle. So this is a bit of reassurance that this seemingly unrelated approach of anti-differentiation produced the same area calculation as our basic triangular calculations that we know and trust. Let's take a look at another example, just to get some more practice. We're going to look at the area under the parabola 6x squared between 0 and 5. 1, 2, 3, 4, 5. And some parabola shape. We won't get this evenly scaled just because the scale is so huge. This would be 25 times 6, that would be 300 on this axis here. This area we would not know how to calculate from first principles. There's no common shape that we can build this out of, but we can do it using integrals. The integral from 0 to 5, again, these are x values, of 6x squared dx. That's our little f of x. And I'm going to jump straight to the antiderivative version. We would have 6x cubed over 3. Add 1 to the power, divide by the new power. The 6 is a multiplier, constant, it stays around, and that's going to be between 5 and 0. I'm going to skip the plus c here, and I want to show you again why. If I were to put a plus c in for a definite integral, one where we start and end at specific locations, we're always going to have plus c minus c. So we can skip the plus c with definite integrals. That's where we have limits of integration involved, or integrals with limits. And that's just because the plus c and the minus c cancel later on, so we can save ourselves some work. If we believe this is the antiderivative, we can plug in 5 and 0. And in fact, if you want to simplify your life, I usually pull the constants out front. So this 6/3 can go all the way out front, and then we can just talk about x cubed to the 5 cubed minus 0 cubed. Again, it's just a tidying measure that saves a little bit of space and avoids some plus and minus kind of errors coming out. That 6/3 is just 2 times 5 cubed. 5 cubed is 125, so we'll end up with 250 square units here. And that would be the area underneath the parabola 6x squared from 0 to 5. Without calculus, that's a pretty complicated thing to even try to get a handle on how we'd get that area. But with calculus and the fundamental theorem of calculus, the answer just pops out as a calculation answer.